So you have to, is it clear now? So it is clear now?
Yes, sir.
Okay, right.
Yes, sir.
So, so you have to, what will have, you have to avoid the condition. So avoid the thermal runaway. You have to avoid the thermal runaway. So what are the conditions you have to place in order to avoid the thermal runaways? So first condition is to avoid thermal runaway is to the heat, whatever the heat is generated or released at the collector junction must not exceed the rate at which the heat can be dissipated. Okay. So this is the general case. Whatever the heat is generated, it should not exceed the heat whatever it is dissipated. Okay. So whatever the heat is generated, the rate at which the heat is generated should not exceed the rate at which the dissipated. So that is the condition, first condition to avoid the thermal runaway. So dou Pc by dou Tj, it should be less than the dou Pd by dou Tj. So what is the Tj? Tj is the junction temperature. So Pd is the power in watts for a dissipated in collector junction. Okay. So theta is the thermal resistance or a power of a transistor. So what is that meaning? Dou Pc by dou Tj is should be less than the dou Pd by dou Tj. Or dou Pc by dou Tj is should be 1 by theta. So where theta is the thermal resistance of a transistor. Okay. So is it clear? So what is the first condition? What is the rate at which the heat is released at the collector junction should be less than the whatever it is dissipated. The heat is dissipated. Okay. So dou Pc by dou Tj should be less than the dou Pd by dou Tj. You can also call as a dou Pc by dou Tj should be less than 1 by theta, where theta is the junction resistance. Okay, or thermal resistance. Junction resistance or thermal resistance of a transistor. And the second condition is the most important condition. So what is that? So VCE, what is the VCE? Collector to emitter voltage. So our output voltage should be less than the VCC by 2. Okay, it should main condition and very useful condition. So what should be there? The operating point should be chosen such that VCE should be less than or equal to VCC by 2. For example, if the 15 volts VCC you are given to the circuit, you should maintain the VCE which is less than or equal to 7.5 volts. Okay, so that will avoid the thermal runaway. So they are the two conditions which will avoid the thermal runaway problem in the any type of power amplifier circuits, because the power amplifier uses power transistor. So the power transistor always used in the circuits where the high power is related. So high power is related means the high power dissipation also there because of the high heat generated. So in order to avoid this, you should maintain some conditions. So that conditions code you can call as a avoiding the thermal runaway conditions. The process you are avoiding is called a thermal runaway. So that conditions, what are the conditions you should be applied is, so the rate at which the power is released or heat is released at the collector junction should not exceed the power dissipated, okay, or heat dissipated, okay. So that is the first condition. And second condition is to, you should maintain the collector to emitter voltage, you can call as the output voltage should be less than or equal to the supply voltage divided by 2. The supply voltage or VCC by 2. So there are the two conditions to avoid the thermal runaway. So and so there are the distortions. So we have not in the syllabus actually. So you will go for this. What is the necessity of heat sink for a power transistor? So what is the necessity for a heat sink for a power transistor is to, so what is the heat sink actually you have to learn. So what is the heat sink means? It is a aluminum metal that is encapsulated onto the power transistor. So it is the heat sink is a device or a Aluminium. Mainly it is made up of the aluminium metal. So it is a metal that is made up of with the aluminium. Okay. So that is should be incorporated or encapsulated onto the power transistor in order to absorb the heat generated where it is the high power ratings you are applying in the power amplifier. Okay, is it clear or not? It will absorb the heat, though it will sink the heat. That is the reason you can call it the heat sink. It will sinking the heat. So that means it will absorb the heat means so the power dissipation is less. Correct or not? So it will absorb the power heat means so whatever the generated is sink by using this heat sink. So what will happen? It will protect it. The power transistor is protected from heat burnt. Okay, so you can avoid the destruction of a power transistor by placing the heat sinks nearby the power transistor. Okay, so in the power amplifiers we are using a power transistor, and the power transistor is protected by using these heat sinks. So what are the heat sinks? Means this it will sinking the heat. So whatever generated, the power is generated which is in the form of heat that is sink by using these devices. It will absorb the power, absorb the heat. It will absorb the heat. Okay. So you can also call as a cooling device. You can also call as a cooling devices. This is you can call as a cooling device because it will absorb the power and whatever the power heat is generated that will be absorbed and it is dissipated in the environment. Okay, so is it clear or not? Actually whatever the power is generated or heat is generated, it is destroying the power transistor. So if you are placed this heat sink nearby the power transistor, it will absorb the whatever the heat is there and it will cools the power transistor, and whatever the absorbed heat is now it is dissipated in the environment. Okay, so in the outside world it will be environmentally it will be dissipated. So what will happen? So it is protected. Now the power transistor is protected. So the heat sink is a metallic heat conducting device placed in close contact with the transistor to increase the dissipation capacity of the transistor by reducing the total thermal resistance from the junction to the ambient. Okay, and if you are a larger size of the heat sink, smaller will be the thermal resistance. Is it clear? If the size is more, the absorbing capacity of the heat sink will increase. So what will happen? So more heat will be it will be absorbed. So what will happen? Sink or absorb. So what will happen? So overall the capacity of the production capacity of the power transistor will increase. Correct or not? So more and more heat is absorbed by the heat sink means so generally you are protecting the heat power transistor. So this is the your heat sinks. So what is the necessity of heat sink is what is the main purpose of the heat sink? It will absorb the heat generated, unwanted heat, whatever there it is generated, it will be absorbed by the or sink by the power, power or heat sink. So what will happen? And it is also dissipated in the environment or outside world, and it will protects the power transistor from self-destruction or thermal runaway. Okay, what is the thermal runaway or the self-destruction process of power transistor? So heat, whatever the heat is generated in the process, so in the circuit that is destroy the power transistor. What you should do? You should maintain some conditions. So even though the conditions is not satisfied or fails, so what will happen? You have to place some external device. What is the device you can call as a heat sink? So heat sink is mainly made up of the aluminum metal plate. So it is a metal plate which will absorb the heat and will dissipate the power in the form of heat in the environment. So it will protect the power transistor from the unwanted or unnecessary destruction of the power transistor. Okay, so this is the purpose of or necessity of the heat sink. Okay, so next what is the different types of heat sinks and their mounting methods? So they are there are three types. So push on type and metal tab and collector tube case. So there are the three types of heat sinks are present in the market. So what are they? Push on type, metal tab, collector to case. So what is the push on type is? This is a push on type. So this is also called transistor type. So transistor type means it will pull. This is the device heat sink you can call. You can say it is a heat sink. So this is heat sink is placed onto this device. What is the device? It is transistor. So onto the transistor itself you will place. So it is push on type. So next one is the metal tab. So this is the transistor. Onto this you will place some metal case. So this is metal case. You will have metal, aluminum metal you are placing. So you can see in the circuits, in the projects, if you've seen this type of aluminum plates or aluminum metal types, you will have onto the transistors or any components. Okay, not only transistor, it may in the voltage regulators, 7815 7809. So like this, and regulators, all type of electronic components, mostly they will use this type of heat sinks. So what are the push on type means? This is the structure, this is the push on type. This is the which will place onto this device transistor. So this is a metal case which is directly attached to the device. So what is the other thing? Collector to case heat sink. So in the itself, the collector onto the terminal, collector is connected to the case directly. The collector terminal itself connected to the case. So it is a case. This is called a case. So in this case, the case is acts like a collector. So collector is directly connected to the this case, and whatever the collector current, what is that? IC. So IC it is generated, which is directly dissipated to this case, or it will absorb to this case. Is it clear? There are the three types of heat sinks. What are they? Push on type, metal type, and a collector to case. So and how to place means this is the process of mounting. Already we have seen. So how to mount means, so it is placed onto the this transistor. It is directly attached. It is also attached to collector directly. So here, so there is a two terminals only, emitter and base. The collector is acts like this case. The collector is directly it is case. So the case is absorbed directly because the current is generated at the collector only and will be absorbed through this case. Okay. So they are the mounting methods as well as the heat sinks, different types of heat sinks. So you can call it metal tab or metal can. You can also call metal tab. Okay, push on type or round type or transistor type. This is called the push on type or transistor type or round type. This will be metal can or metal tap. This is the connector to case. Okay. So they are the three majorly used heat sink methods or mounting methods. Okay. So and this is the today class. We will discuss the next class tuned amplifiers separately in the next class. Okay. Is it clear, all of you? What is
Yes, sir.
Yes, sir.
heat sink?
Yes.
Tell me. What is meaning of heat sink? What is the meaning of heat sink? No one is responding. What is that? Heat sink is a
Cooling devices.
metal metallic structure or a metallic device, or is made up of
Device.
mainly with aluminum,
Conducting.
which will sinking. It will absorb the heat produced in the power transistor. Okay, very simple, very easy to understand. So in order to avoid the power dissipation, in order to avoid the self-destruction of the power transistor, in order to avoid the thermal runaway, so we are placing the heat sinks nearby the power transistors. Okay, so this can be a metallic can or metallic heat conducting device, metallic heat conducting device. Okay, heat sink is a metallic heat conducting device which is placed in close contact with the transistor to increase the dissipation capacity of the transistor by reducing the total thermal resistance from the junction to ambient. So this is the technically you will have the sub definition. But what is the general meaning? It will the metallic piece or a metallic can or metallic device structure that will be placed nearby the power transistor in order to dissipate the heat in the environment or outside world. So in order to protect from thermal runaway by self-destruction of the transistor, by the self-destruction of the transistor. Okay, is it clear why the thermal runaway is getting prominent in the power transistors only, not BJT? Is it clear? Whether my question is clear? Why the self-destruction process or thermal runaway is mainly caused in power transistors? So because what is the reason? Main reason is that it is having a high power ratings. So in the high power ratings, high leakage current is there, or reverse saturation or magnetic charge carriers are more. So thermal runaway, it is more prominent in the power transistors because of the reverse saturation current. So because that it will increase the heat. So IC increases, heat is increased, IC is increased like this. So it is a circle process of circle. Okay. So that is the reason it has a more prominent, and you have to avoid through these conditions as well as the heat sinks. So I will wind up this class today. So I will also post the lecture. See in the your group.